You're here for help. I read your mind. I know. You're not here. You just didn't click the title. You're here. You're like, wow, I compared my DVR to Steele's, and mine looks like the inside of a college student's microwave after 3 semesters of Hot Pocket explosions and ramen shenanigans. It's just not good. Never good. Never look at a college student's microwave and never had bad DVR. Don't do it. It's just not a good idea, okay? It's FPV. Our DVR should be amazing. What we see should be amazing. Digital is a thing, analog's a thing. My DVR is good on analog. Why? I'm gonna explain that in today's video because it's kind of an important thing, and it's also very nuanced. You need very specific gear that's quality to do specific things. Not all the gear that I'm gonna be using, I'm gonna suggest, but you know, I'm gonna tell you why mine works, and maybe it'll help you understand why yours doesn't work. So before we go any further, I wanted to announce that I did start a Discord server. It's called the Mr. Steele Official Server. I was gonna say Discord, but it's just Mr. Steele Official Server. The link in the description below, you can check it out, it's free. I do Q&As on there every week, and I also have a Patreon thing where we're gonna do like a VIP section, and you guys can get together and we'll do some hangout stuff. I'll talk about the Patreon stuff at the end. But let's go ahead and get into this video. I appreciate you guys taking the time out of your day to come over here and listen to me talk about videos and quality and gear. So first of all, let's dive into the systems. We'll go through a quick rundown of how video works. So you have a video camera on the drone, starts out, sees an image. Image goes into the camera, gets deciphered, then thrown into a video transmitter. The video transmitter outputs at whatever power output you have, which we'll talk about here in a minute, out of the video transmitting antenna, through the air, then gets captured by these antennas, which are listening, which are your receiving module antennas. You have an omnidirectional up here, which is listening in a donut orientation. The top is not good, the bottom's not good, but on the sides are very good. And this is what's called a directional antenna, which is focused in one pie slice area, but it listens very, very precisely in that pie slice. So if you're outside of the pie slice, then it's gonna be using this one. So it receives that. I'll get into more detail in this stuff in a little bit. It receives a signal here, then it goes into the goggle module, it's deciphered, and then thrown into your LCD screens or OLED screens, depending on what kind of goggles you have. So that's kind of the rundown of how video works from start to finish, as far as what you see on the drone and then how you end up seeing it in your goggles. Now let's talk about the individual systems and why they're so important. So first of all, the main system that you're gonna have to worry about is the drone. Obviously, this thing is flying, it's seeing things and then relaying that information back to you. So you have a video camera, you have maybe an OSD or on-screen display on board, you have a video transmitter, and you have the video transmitting antenna. Ultimately, there's a lot of RFI and EMF coming off this drone, which those are radio frequency interference and electromagnetic interference. Both of those things are interacting with everything that's going on this drone. So you have a speed controller with sending output power to your motors. The motors are sending off RFI or EMI back into the drone. There's a lot of interference and it can mess up a video signal very quickly. The best way to mitigate that is keeping your wires as short as possible and also having really good filtered power. So I'm gonna run through the components that I use and talk about why my particular drone has really good filtered power, and then we'll get into some other systems like the goggle receiver and goggle module and stuff like that. So first of all, we have the video camera. This is a Runcam Swift Mr. Steele edition. It's the V3. It's got a GoPro 2.5mm lens on it. For me, CCD camera is the best camera. I just like the consistency of how it works. I don't know. There are CMOS cameras and there are CCD cameras. CCD are basically old security cameras, which were the beginning of FPV. And then recently in the last few years, CMOS has taken over. CMOS is like more what you're gonna see in like a digital camera or even digital FPV. It's susceptible to rolling shutter, which if you've ever seen a video of like a helicopter and the blades are stopped, or a car spinning a wheel and the wheel is seemingly stopped, that's essentially rolling shutter. Where CCD doesn't suffer from that, but it's not really that big of a factor in FPV, but I'm just kind of giving you a way to differentiate between the two. CCD doesn't deal with bright lights very well, but CMOS seems to do that. But there are different latencies. Some of the CMOS cameras are better in latency. CCD seem to be more consistent, and even though I find on paper CCD cameras tend to have more latency, it's not perceivable to me. I've tried CMOS and CCD together, and I still prefer CCD. I know that was a lot of information on cameras. However, all you need to know is I'm running a CCD camera and I'm running a big lens, which is the GoPro 2.5mm lens that allows the most light and the most high quality image that I think I can get on an analog camera. So that comes in, and then it goes to what's this board that comes with my drone, which is actually why it's so expensive. So if you end up buying an Apex, you can buy it without electronics, or you can buy the Mr. Steele version that comes with electronics. And those electronics are an OSD board that sits right here behind the camera, and a regulator board that comes back here and sits in the back of the drone. What that does is it allows you to hook your video camera up to a little tiny cable that solders onto this OSD board. Now the OSD board is exactly what it says. It's giving you on-screen display, but then it's also linked to what's back here, which is your regulator board. And what that regulator board is doing is it's taking the 25 volts that's coming out of the battery, regulating it down to the 5 volts that you need, but it does it in a very trick way. It has what's called a cascading regulator on it. So it has a switching regulator, which turns on and off very fast to give you a desired voltage. Say 25 volts, we want 6. It's going to turn on and off as fast as it can to allow only 6 volts to pass through. And then you have what's called a linear regulator, which turns the rest of the voltage that you don't want into heat. It's not very efficient. You wouldn't use it for something 25 volts down to 5 volts because it would be turning 20 volts into heat, which is very inefficient. But you don't want a switching regulator only, because that switching can actually cause interference in the system. So it has both, and it's called a cascading regulator, and it's very, very cool, and it works really well, and it gives you probably the cleanest video that you can get out of an analog drone as far as this system is concerned, and it's all, you know, ready to go and tried and true. So that's why my particular drone seems to have very clean output for as far as video, is because I do have these extra boards on board that are, you know, the switching regulator with the linear step down, and then also how short the wires are, because I have the OSD board right here, which is where the video camera comes in, and then also the video transmitter is soldered onto another about 1-inch wire, which if you have anything wire related, twist them, all of them, twist them. It keeps down on the RFI interference. Just make sure you twist all of your wires together so that it basically mitigates a little bit of RFI. So again, short range of wire. We have video camera, little tiny wire going to the OSD board, little tiny wire coming out, going to the video transmitter. This is a Unify Pro V3, it's a 5 volt Unify, and the reason I use a 5 volt is just because it's smaller and it's simplistic. I don't use smart audio, I don't use any of that stuff. I just try to keep it as simple as possible. I feel like at the end of the day, it's just easy to keep things simple, and when you do, it makes things work better. The more complex things are, usually the more complications you have. So I'm running into the Unify 5 volt at 800 milliwatts. I always run the highest output that's available, just because I don't fly with that many people, and when I do, we just separate on channels. Like I use race band 7, race band 8 usually, and most people fly on 5 and 1, and we're good to go. So again, like 800 milliwatts, maximum output power. Then video transmitting antenna. This is very important as well. It's just important that you have something that's not broken or not going to get damaged, because if this is damaged, it can also burn out your video transmitter, because it doesn't have the right resistance, and it will ultimately make the video transmitter too hot and it will burn it out. So you want to make sure that this isn't going to get broken, but you also want to make sure that it's in a position where it's not necessarily blocked by anything. So you want to try to separate it from the drone as much as you possibly can without it being too obnoxious and sticking off. But at the end of the day, really, it just comes down to making something that's going to be a decent quality antenna, but not going to be broken, because the worst thing you can do is break an antenna and not know it's broken, and then you're going to get bad reception and not know why. So that's why I've used this Triumph Pro for the last year or two since it came out, because it's tiny, and this is the original one that I put on there like over a year ago, and it's never been broken. So again, small antenna that's not going to get broken, that's separated from the drone as much as it possibly can, without being too obnoxious and invasive in catching things, and that's kind of your drone system. That's as cleanest as possibly you can be. That's the cleanest thing that you can do as far as having your system done in the right way, is mitigating RFI and EMI interference, and then also getting a good camera, getting a good video transmitter, running at highest output volt or highest output power, and then having an antenna that is going to be of decent quality but not going to get broken. Next, so your video is in the air. You're gonna go to your goggle system. You're gonna figure out what you need on the goggle system. So when we're talking about goggles here, I think the most important thing out of all FPV is having good receiving antennas and a good receiving module. If you're on digital, it doesn't matter, because there's only one receiving module, and that's just in the DJI goggles. When we're talking about analog, there are many options. I'll talk about the antennas first, and then we'll talk about modules, because modules can be subjective to, even though they have the same hardware. I'll talk about that in a second. So the hardware can be different even though it's the same as far as quality. So we're coming in, signals being picked up by our receiving antennas. These are listening. This one is in a pie slice, as I said earlier in the video. It's listening very specifically to one area, but it also listens in that one area really well. So you can go much further in this pie slice than you can with this omnidirectional. So that's why this is here. And then you have this, which is your omnidirectional antenna, which again is placed high above your head so that it can receive not through water. Your head is full of water. I mean, I don't know. Anyways, your head has water in it, and water blocks 5.8. It blocks higher frequencies. So the higher it is, the better. The higher off the ground, usually the better reception. Anyways, think of a donut radiation plot on this. So this is listening outward like this. On the top and bottom, it's not listening very well. So if you fly directly above yourself, you're gonna have bad video. If you fly laterally from yourself, you're gonna have good video. If you fly directly out into this pie slice, you're gonna have even better video. Now, let's get into, well, I gotta talk about these antennas. These are the ETHiX antennas that are made with VAS, so Video Aerial Systems. I collaborated with them. We have a Video Aerial Systems ETHiX Mad Mushroom V2 with a 5.5 inch extension and a 90-degree SMA that's reinforced. And then you have this, what is it, a Crosshair Extreme, which is a 6-lobe antenna in a tinier package as far as the backplate is concerned to make it a little bit more travel friendly. And it comes with a 45-degree angle mount as well so that you can orient it in the way that your head is facing. I see so many people orienting their patch antennas off the side of their head, and then they're trying to figure out where they are in the goggles, and they're like, well, I'm looking over there, right? And then the goggle antenna is pointing that way, and it just doesn't work. So if you face it the same way that your body's pointing, then it's very easy to orient yourself even when you're in the goggles. So next, we're gonna talk about goggle receiving. The goggle receiver module, okay? There are many goggle receiver modules out there. There are really cheap ones, there are really expensive ones. The really expensive ones and the really cheap ones have very similar hardware, if not it's the exact same. However, when these things are made, when they're designed in the factory, they're all built at the same time and then they're tested. It's very much like video cards or batteries. The ones that test really well are thrown into one bin, an A bin. Then the ones that test mediocre are put into like a B bin. The ones that test poorly are put into a C bin. The cheaper modules are sold to the cheaper the cheaper suppliers that want to pay for the cheaper stuff, which is the C bin. And yes, it still works, it's just not as optimized as the stuff that was put in the A bin. And then the guys that are paying a little bit more money for the modules, aka usually the top 3 guys that are making goggle modules or receivers, then they're paying for the A stuff so they can get the highest quality. So when you're talking about cheap versus poor, or cheap versus inexpensive, or cheap versus expensive, you need to just go ahead and buy an expensive module. This is FPV. You need the best video possible. If you have a crappy receiving module and crappy receiving antennas, I guarantee you're gonna have a bad experience, and that's just end of story. So please, if you're gonna skimp on anything, don't skimp on the video receiving module or the receiving antennas. Get good antennas and a good module, and you will have a better experience than you ever thought you could with some garbage like $20 Banggood receiving module. And yes, there have been cases where some of those have worked really well for people, but in overall, it's a gamble with a cheaper module than it is with something more expensive. Also, there are more people using the more expensive stuff, so if you have questions, you can ask. There's also customer support. Just, again, spend a little bit more, it's not that much, and buy something that you know is gonna be quality. If you have an issue with it or it's not performing in the way that it should, contact the supplier. Get a new one. That's the cool thing about spending a little bit more money. You get customer service. So this is a TBS Fusion. This is an antenna receiving module that blends signals together like the rapid fire or the clear view. So it takes both of these signals and then blends them together and gives you the best optimal image that you can get. The next thing is the goggles, which again aren't really part of the reception, but it is deciphering that in the receiving module and then giving you the output here. If you can't see, you can't fly. Buy decent goggles. If the goggles are like too dim or the screens are fuzzy or whatever, it's just not gonna be a good day. So you're flying FPV. Just make what you see the best possible thing that you can possibly see, and then you'll have a better experience. So I'm not advocating you buy Fat Shark HDO2s or a Fusion module or these antennas or my drone or whatever. All I'm saying is if you're trying to optimize your video systems, then you need to optimize the gear that's involved, and you need to reduce the amount of EMI and RFI that are coming into your video signal. Also, flying in certain locations, you can check the noise floor on some of these receivers and understand what channels are better or not to go on. I can do another video on that, but inside this goggle module, you can check the spectrum and say, hey, like there's something on channel 5. I don't need to fly on channel 5. I want to fly on channel 7 or 8 so that I can have a clearer signal here. So you check all of these things before you fly, and then you ultimately have the best possible video you can because you've optimized your gear. You've also optimized your gear for the environment by changing to a channel that isn't taken up in that particular day or particular environment, like I said. So that is analog video in a nutshell, and as far as optimizing your gear, it's kind of difficult to do. It took me years to figure it out, but ultimately the best thing I can tell you as far as advice is concerned is spend money on the receiver and spend money on the receiving antennas. Everything else you can kind of skimp on, but obviously the more you spend and the more time you spend trying to refine it, the better end result you're going to have. You can have a crappy drone, you can have terrible filtration. For the most part, everything's figured out these days and most filtration's pretty good. But when people are concerned about why my video is exactly the way that it is, this is why. Because I spend so much time trying to reduce EMI, RFI. I've tried to simplify everything as much as possible. And I've also optimized these systems to work together. Now, when people ask me, should I buy DJI or should I buy analog? Again, like, this is a lot of work to get a really good image quality out of analog, and a lot of people just, you know, use mediocre analog signal and they're good to go. That's why I say beginners, just get digital. If you don't want to tinker with it, digital. If you don't have it figured out, or you don't want to follow someone that's figured it out, you don't want to use their gear, you just want to try to figure it out on yourself, then you're going to spend a lot of time unless you buy digital or unless you go down a path that you have the time to tinker. So again, I hope you learned something in this video. I did want to give a little shout out about my Patreon supporters that I haven't been paying attention to for the last year or so, because I just made a Patreon and people started paying me for no reason. And I thank you guys so much, and I'll just give you a shout out because I haven't done anything special other than create videos, and I think these guys are just overall nice people that wanted to support me and didn't know how to do it, and this was a way. So let me give a shout out to Harley Gilbert, Maximilian Wolf, Yogi B, Jacob Barron, Ken Towner, Ed Dibbler, Jay Nico, Quentin Hansen, David Owens, Simon, Thomas Neville, Felix Bowman, and Peter Wario. I can't say it. W-A-I-R-O-A. Waria. Yeah. Peter Waria. Sorry about that. I'm sorry I butchered your name. But thank you guys so much for supporting me. If you guys want to, you can go and check out the Discord server. It's free. Again, we're gonna do Q&As on there. It's gonna be dope. And I hope you guys enjoyed this. Let me know in the comment section what you learned or what you didn't learn, and I will see you in the next video. Thank you so much for taking the time out of your day to come join me and listen to me ramble about FPV, because I do actually really enjoy it. I do enjoy sharing my secrets, because ultimately it's about having fun. And if you guys aren't having fun, I'm not having fun. If I'm not having fun, then you guys aren't getting content, so then you're not having fun. So see you guys in the next one. Peace.